Okay, so the reason why this video is called Review B is because we did Review A yesterday and most of you were here. So we're starting with number 13 on the actual test. I'm going to show you a sample of it and how to do it. It says on number 13, let f of x equal, I'm going to make this up so it'll be kind of like this one. It says on 13, f of x equals, we'll say 1/4 x to the 3/2. G of x equals 6x cubed. And the instructions are, after they give you those two things, that's the first thing they hand you, and then they say find f times g of x and f over g of x, state the domain of each, then evaluate them at 9. So we need to find f times g of x. They write it like this. It's got a great big huge heavy dot. That does not mean compose. Compose is when the dot is open. So it does not mean compose. When it's a colored in, it's a rather heavy dot. It means times. So this is the way they've written it. It says find f times g of x. You've seen me all the way through the chapter write it like this. It means the same thing. Okay? Big old heavy dot that's colored in means times. All right, so we'll write it the way they wrote it. We're supposed to find f times g of x. That means to multiply the two of them. So I will have 1/4 x to the 3/2 times 6x to the 3rd. And you got to do the work on it to get it as cleaned up as possible before you report it for the answer. So I've got 4 things being multiplied. I've got the 1/4, the x to the 3/2, the 6, and the x cubed. They're all being multiplied, and I can multiply 1/4 times 6. That would be 6/4, which reduces to 3/2. Yeah? Okay with that? X to the 3/2 is the same. Well, x to the 3/2, when I multiply times x to the 3rd, means I need to add these two together. You can get your calculator to do it, or you can call that 3 6/2. That would be 3/2 plus 6/2 is 9/2. One thing I don't want to see, because I don't know if you know yet, but I hate mixed numbers. So do not write this. I will mark it wrong. Well, not completely, but a piece of it wrong. Do not write 4.5. That is not an exponent. Not in a class like this. You write it 9/2. Okay, so there's f times g of x. Question is, what is its domain? So this is what I would put in the first blank. It says f times g of x equals, and that would be what that blank looks like. And then underneath it, it will have another blank like this, and it will say d colon.
Is it all positive?
Why do you think it's just positives?
Because the x is 9/2, and 2 is a positive.
It's an even.
An even.
Yeah. This means to square root something, and you can only square root positives, right? Which means x raised to something had better be a positive number. So x is greater than or equal to 0. Has to be. If this were a 3 down here, well, then that wouldn't be a 9. It would have reduced to 3. But if I had 11/3 for some crazy reason, then it would be all real numbers. You see that? Okay. And the next blank will say f over g of x. So I need to find that. So I take f, which is 1/4. Well, f over g of x is going to be 1/4 x to the 3/2 over 6 x to the 3. And that's kind of off center there a little bit, but I wish to reduce that fraction some way or another. And if I have 1/4 over 6, do you all know how to fix that up? When you have a fraction divided by something else, you multiply by the something else's reciprocal. Do you recall that, or do you want me to show you? Can I show you? In grade school, they had you do fractional division, and the way they wrote it almost exclusively was like this. They would say something like 5/7 divided by 3/4. And you immediately were taught to write 5/7 times 4/3. You take the second one's reciprocal, and it turns it into a times problem, because you're doing the inverse of dividing, which is times it. You see? And that's what you would do, and you would get 20/21. I'm here to tell you that that problem right there could also be written this way, but they never do it for you in grade school because I don't think the teachers understand it. That's another way to write that exact same problem. This is a horizontal writing of it. This is vertical. This is what you see in algebra. This is what you see in grade school. It's the same thing. It is 5/7 divided by 3/4, which means that it is 5/7 times 4/3. You flip it over, which gives you 20/21. You see what I'm saying? So if you've got 1/4 divided by 6, that's the same thing as 1/4 times 1/6, which is 1/24. Can you handle that in your head? Everybody see what happened there or not? Some of you are not nodding at me. You see what's going on?
Yes.
You sure? Okay. And then here we've got things with the same base being divided. That means we subtract them. What's 3/2 minus 3? Well, that's 3/2 minus 6/2 if you have the same denominator, which is -3/2, right? I would accept this, although I would be frowning while it should be this. You should take that negative exponent and put it where it's not. This is in the numerator. You're going, how do you know? Well, because this minus this was a negative. Well, the result is in the numerator. But if that turns out negative when you subtract it, it really belongs in the denominator to make it positive. So this is what I would like to see. This is not wrong. This is better, though. So over here in this blank, you would write, if you wanted to keep me happy, 1/24, x to the 3/2. And then down below that, it would have a domain, blank. What would be the domain of this one?
Domain is greater than 0, but it's not equal to 0.
Good. It would have to be greater than or equal to 0 when we consider just the square root, for the same reason this one had to be greater than or equal to 0, because we are square rooting. That's what that means. But the equal part is also eliminated because if x were equal to 0, that would make the denominator 0, which you can't have. So the domain here is x greater than 0. Okay? Now, what if this had been, instead of having a 2 here, just pretend with me for a second that this was 3/5, just for the fun of it. What would your domain now be?
Everything except 0.
Everything except 0. And if you wrote those words, I'd give you full credit. This is the shortcut way of writing this domain. X's not equal to 0 are in the domain. Why can't it be 0? Again, division by 0 must be eliminated in the F/G thing, if necessary. You see what I'm saying? That would be one of the dangers of leaving this the way it is, because you might think that's in the numerator. It really isn't. When you see it in the denominator, perhaps it'll help you remember you can't divide by 0. So, but since this is not a 5, since it is a 2, which means we can't square root negatives, nor can we divide by 0, this one coming back to being correct should be that. Y'all see? Okay, and then we got 2 more blanks to go with this, which I don't have room to put down here. And it would be, this is how it's asked. It would say, what is F times G of 9? We'll say it's 9. What did I say it was before? Did I say it was 9? I think I did. All right, so F times G of 9. That means we need to take F times G, which is right here, and plug a 9 in here. That's going to be huge. But you can make your calculator do it. And I'll give you answers, or full credit for a decimal equation. I would really rather be a fraction. So what you would do is you would take 9 raised to the 9/2 in your calculator. That's what I would do first anyway. And then take it times 3/2. Or you can put it all in at once. If I put it all in at once, it would be parenthesis 3 divided by 2, close it. And then parenthesis 9, close it, raised to the 9/2. Oops. Like this, those of you that are viewing it. Okay, and then I hit enter and I get a rather large number, 29,524.5. Okay, so in this blank right here that says this, you would write 29,524.5. And then there will be another one right below it that says F/G of 9. Same evaluation. We go back over here to our F/G thing, and we would take 1 divided by parenthesis 24 times 9 raised to the 3/2. Close the parenthesis. Nope. Get out of there and close the parenthesis like that, like this. You can see that. And then enter. And I get a tiny number. Did you get a tiny number? 0.001543? That would be enough. 0.001543. And if you stop there, it would be nice if you would put a dot there, indicating that you know this is an approximation. You're acknowledging that. But you don't have to. It won't be wrong if you don't. It's just a nice thing to know. A nice thing to use. Lets the reader know you know what you're doing.
So would a problem like this be worth 6 points?
This part right here will be worth 3 or 2 or 3, depending on how difficult it is. This will be worth 1. This will be worth 1. So if you put the equal sign there, you just lost it. This will be worth 1. This will be worth 1. This may be worth 1 or 2, depending on the difficulty. So it's worth a lot of points. One thing that I will read with you. If you get the wrong thing here, but whatever you get here, you plug in the 9 and get the correct answer. When you plug 9 into your wrong answer, you will get that one right. But not that. Okay. It's called reading with you. Are you with me, everybody? Got it? Okay. Number 14 takes the most explanation of all because, I don't know, you guys are supposed to be pretty good writers by now. I mean, you guys do so much better on the ISAT in English than you do in math. And yet, whenever I ask you to write something in math, no one seems to know how to do it. And you are going to have to write on this next problem. This next problem altogether is worth 9 points. 3 of those points are your explanation, and it has to include all the pieces mathematically, or you don't get credit. So, I think I had a sample problem somewhere. Just a minute, it's in here someplace. Okay. So the instructions, I guess I need the words. The instructions on this will say something like this, number 14. And by the way, and I know you probably can't see any details, but on number 14 base, you got a lot of writing to do to get the answer to that. Okay, not a lot of writing, a lot of things to get all the points. Here's what it says. Solve the inequality and the equation and describe the similarity and difference between solving radical equations and inequalities. So I'll get the stuff written down here and then you will. So it says solve the inequality, and here's a sample. 3 square roots of x minus 2 plus 5 less than or equal to 14. So that's the inequality. Solve the inequality and also the equation, and the equation looks just like it. 3 square roots of x minus 2 plus 5 equals 14. So it says, solve the inequality, solve the equation, and then when you're done with that, you are to describe the similarity and difference. In other words, compare and contrast. You've done that a lot in English, haven't you? I'm going to tell you what I'm looking for in the compare and contrast as soon as we get these solved. I want to do the equation first. It's easier. Okay? So if I solve the equation first thing I'm going to do is get rid of the 5. So I would expect to see you write this down and then write this down. You don't have to show me what you did, just what the result was. Yeah? And then divide by 3. And then square. And then add. Okay? Doing that and getting it right will get you 3 of the 9 points. You following me? To do the inequality, you do exactly the same thing. The only time the inequality flips directions is if you end up multiplying or dividing by a negative somewhere along the line. I never did that. I subtracted, I divided, I squared, I added. You add or subtract, nothing's going to happen. Multiply or divide, nothing's going to happen. So long as what you're multiplying and dividing by, that's the only place it happened right there. Forget to hear from here. If that's a positive, That's not going to change. So we treat that thing just like an equal sign unless you have to multiply or divide by a negative. And I'm going to tell you right now, you will not be called upon to multiply or divide by a negative. I'm not going to try to trap you on the test. It'll be very similar to this. That's not what I'm testing here. So over here in this one, you write this down on a piece of that big blank space, and you do the same thing. Show me the same thing. Don't just say, oh, it equals this and because of this over here. Don't do that. You got to show me everything. So it'll be 3, x minus 2 less than or equal to 9. X minus 2 less than or equal to 3. X minus 2 less than or equal to 9. X less than or equal to 11. Except this is the biggie. This is what will get you the points for this one. Getting to here will only get you 1 point. That will get you 3. This will get you 1, because the important part of this is not that you can solve it. You showed me it there. The important part of this is that you also consider the fact that you cannot square root a negative. So in this solution right here, this says that any x that's less than 11 will work if you leave it like this. That's why you only get 1 point for it. Because not any x less than 11 will work. For example, negative 100 would fail. And negative 100 is less than 11 because it's way down on the number line below 11. You with me? But negative 100 would cause me to square root negative 102. Which you can't do. So what I'm saying is x has to be less than or equal to 11, yes. But it also has to be more than or equal to some value of x that makes us square root positives or 0. So what I'm saying is to figure out this number right here, you have to consider this. This is the other part I expect to see. You have to understand that you have to find an x minus 2, which is more than or equal to 0, or you can't square root it. Which means that x has got to be more than or equal to 2. See where x is sitting? It's less than 11, but if I just use that exact same x is more than, because it's on the fat side, x is more than or equal to your lower boundary, which is 2. This will get you 3 points. You see that? Now, can you explain the difference? I'm going to actually write out in words an explanation, which will be on this video if you want to see it. But I'll show you the important parts of the explanation that I'm going to be looking for to get you the other 3 points for this problem. So it says describe the similarities and differences. Here's how I would start. Both. I know what you're referring to by both. Both are solved algebraically the same. But, and here comes the difference. We or I or I'm going to say we, but we, and it's okay, it's fine, but we must consider a lower bound or boundary, just bound, on the inequality to avoid square rooting negatives. I'll get you 3 points. That's just exactly, I mean, that's a way of writing down the thoughts that we had. We got the exact same solution algebraically. That's what the first sentence says. Well, it's not even a sentence, it's just the first part. Comma. That's where they are similar. They're both solved the same algebraically to get to here. Then we had to consider this lower bound to avoid square rooting negatives to get this one completely right. That's what I said. Done. Here's the important part. You have to include the word the same. Solved algebraically would be nice, but they are both solved the same way. Got to have that. That's your similarities. But we must have a lower bound on the inequality to somehow, I don't know if you want to use the word avoid, it seems the best one, but you've got to indicate that we need to not have square rootings of negatives. Those are the important parts. Similarities, they're solved the same. How are they different? Because on the inequality as opposed to the equation, you've got to consider this number to avoid square rooting negatives. That's what I'm looking for. So I've told you how to answer it. Now, let me tell you what happens with kids. They read that, they go, I get that, that's pretty easy, I can do that. But they never actually write it down until test time. Then they can't remember. I would recommend you practice writing that down. Memorize it if you want. But you need to practice writing it, because if you say that and I could do that tomorrow, and then when you actually do it, you don't get it right. A lot of people miss that explanation. Because you understand it right now, but when it comes time for you to express it, for some reason or another, you can't remember it well enough to write it properly. Okay. You all right on number 14? Just so you know, this is the way the answer column is written. On number 14, it already filled it in for you. It says C left, which means I expect to see that to the left. Okay? It would be nice for me to grade it anyway, but I'll find it. It would be nice if you would do this. Just so I know where I'm looking for actual answers. Okay. If we're okay with that one, anybody have a question about that? It's not very hard, but don't forget to consider a lower bound. How would things be different? Just for kicks and giggles here. How would it be different if I started out with this thing being greater than? Then this would be greater than, because I'm never dividing by a negative, so the sign stays the same. Now this is no longer necessary. Because if x is bigger than 11, anything bigger than 11 is going to make you square root a positive. So there's no lower bound on this one. So guess what kind it's going to be tomorrow? Or, sorry, whenever you take the test. Is it tomorrow?
Yeah.
Okay, so guess what it's going to be tomorrow? The other way. So I'm not saying that every inequality says you must consider a lower bound. Only these right here, such that when you get to a solution, it's possible that you could square root a negative. The other way it was, you wouldn't have to do that. And then over here, if it were the other way, you would say they are both solved algebraically and there are no differences. There's a difference if it's pointing that way. Okay, got to be able to consider a lower bound. All right, moving on. I'm going to erase this one and go on to number 15. Number 15 is pretty easy once you have had it explained. That's the reason why I don't believe in giving tests where you have to hit an answer cold for the first time. You have to figure it out. I don't think that's fair. Exercises, yes, it's good to make you stretch your brain, but not on a test. So here's what this one says. I'm going to change the words to keep it secure. It says, write two functions whose graphs are the translations of the graph of, we'll say the graph of function y equals the cube root of x. Are you guys still listening? Okay. Anyway, write two functions whose graphs are translations of y equals cube root of x. And here's what the first one is. It says the first function should have a domain. The first function, so the first one we write is going to have a domain of, say, x is greater than or equal to 4. I'll tell you the next one in a minute. Can you deal with that? Can you write a translation of this or a transformation of this so that the domain of what you're writing is x greater than or equal to 4? Okay, wait a second. I need to change this to a fourth root or this is not going to work. Sorry, let me change that to a fourth root. What does a fourth root look like? Looks a lot like a square root, only it's a little fatter. Okay, it's a little bit, it's got a little bit more of, it's more flat right there, but it doesn't matter. So it's got the same basic thing. That's what the parent function looks like. How are you going to make it? What, by the way, what's the domain of the parent? Greater than or equal to 0. What are you going to have to do to this thing to make its domain greater than or equal to 4? Move it over 4. Make it do this. How do you do that? Minus 4
And the
inside.
yeah.
Yep. So I would write y is equal to the fourth root of x minus 4. So that's not so bad, right? But if it's going to have a domain that's x greater than or equal to 4, you got to move it right or left, which happens on the inside, opposite of what you think. If it said so that its domain is greater than or equal to -4, how would that change it? Yeah, we would add 4 because we would want to move it back here to -4 and open it up, right?
Yes.
Okay. So that's one of them. The other one says, so that its domain is greater than or equal to, I'll go back to +4, like I originally said. That would be what you would write in the blank. There are many, many, many others. I want you to write the simplest one you can think of. I don't want to try to look at all your other junk. I just want to move it. I just wanted this domain to move it over. Now it says, the second function that you're going to write should have a range. So the second one is going to have a range, we'll say, of y greater than or equal to -5. What would you do to the parent graph so that its range was from -5 up? Yeah, move it down 5. Start it here and open it up. Can you see that it starts at -5 and everything above it is expressed? Okay, how do you make that? How do you write that?
Minus outside.
So we write y equals what?
4.
4th root of what?
X.
X, close it, -5. So it's not very hard when you understand what they want you to do. They want you to move it around, right, left, up, down. And you know how to do that with translations. It's just that they're asking it kind of an obscure way. They're saying, we want the domain to turn into this. Well, what does that mean I have to do to it? I got to move it that way. What does this mean? It means I got to move it down because its range right now and its parent function is greater than 0 for the range, greater than 0 for x. If I want to change the domain and range, I've got to move it either up or down or right or left to make it have that particular thing. You with me? Most people don't miss this. They get it. They do just fine. Here's the answer blank on number 15. See, it just says g of x equals, g of x equals. There's 2 blanks. Do the first and second one in that order. So number 15's answer key looks like just g of x equals. Okay. Number 16 is also extremely easy to do. Still, people miss it. And when they miss it, they miss it all. So let me explain. It's another one of those plug and chugs, but you got to do it 4 times. Remember the plug and chug I told you about yesterday with the speed thing and the length of the skid marks? Yeah? Okay. This is just like it, only it talks about, this is what it says. It says the function h of w equals, and it gives you a function. I'll write one on the board in a minute. It says models the height in inches using the weight w of many small female animals. Why female? I don't, whatever. And then it says, use the table to find the height of each of the given animals and record your answers in the table. Round to the nearest 10th. I will ding you if you get the right answers, but you have not rounded each to the nearest 10th. If you just give me some arbitrary answer, but they appear to be correct, but you haven't rounded properly, you're going to miss a point for the problem. It's worth 4 because there's 4 answers. But you will miss a point for the problem for not rounding the way it said. It says to the nearest 10th, so follow the directions. And the equation is something like this. The height as a function of weight, that's what that means, is equal to something like, I'm going to say 4.7 fifth roots of W. I have no idea if this will work out. I have no idea if this will probably turn out pretty funny. But what this is says many small female animals. So this is what you've got, and this is the way the table is put together. It's got 4 animals over here. Like, I don't know. Give me some small animals. Squirrel. Raccoon.
Chipmunk.
I got to tell you this one. What'd you say?
Chipmunk.
Yeah, my little niece, still our family calls him that. She when her dad told her what it was, when she wanted to refer to it later, she called it a monkey chip.
I like that.
Okay, so a chipmunk, a monkey chip, okay, and a rabbit. I'm gonna say a rabbit. Okay, so it's like this, and here it will say, it will give you in this column, it'll say W, it'll say weight up here. And over here it'll say height, and that's what you gotta fill in. So squirrel weighs, did it say it's in pounds or ounces? Yeah, and it actually writes out the word ounces. A squirrel probably, a full-grown squirrel probably weighs 28 ounces. And a raccoon about 98 ounces. And a monkey chip about, not point, we'll say 11.2 ounces. And a rabbit, that's quite a bit, let's say 42 ounces, 2.3 ounces. So you got to plug those in one at a time into this equation. And if you plug one in wrong, it's likely you will plug all the others in wrong. So I want to show you something really, really cool about your calculator, if you want to know this. You can plug all of these in at once and get 4 different answers out at once, if you want to know how to do that, do you? Okay. It's on your home screen. It's on your home screen that you put this in, so don't go to the y equals or anything like that. What you write is 4.7, and then open a brace. A brace is the blue aspect above your parenthesis. Do you see the brace above the parenthesis? So open a brace, and then you can put, I think we have to, let's try this. I know you can use the braces, but let's try this by just putting in these numbers. You go 28, comma. Do you know where your comma is? It's right above the number 7. It's a dedicated key. Okay, so 28, comma, 98, comma, 11.2, comma, and 42.3. And then close the brace and raise that. So you go the raise to it and put it up here to the 1/5 because you got a fifth root all on it. I think that'll work with the braces. We might need a set of parentheses. Try it and see. Oops, the brace raised to the 5th. And it gives you 4 answers, right? Did you get 9.152, blah, 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 and 11.758, blah, 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 and 7 point, did you get a 7 point on the next one and then a 9 point on the next one?
Yeah.
Round out each one to the nearest 10th and put them in the blank. So the first one would be 9.2, right? Yeah, 9.2? Is that not what you got?
I got it.
Okay.
Yeah.
And the next one with it that we see in the sequence is 11.8, yeah? And the next one is, we gotta move over, is gonna be 7.6. And the next one over is gonna be 9.9. And we got that the raccoon's the tallest, which we should, because he's the tallest because he weighs the most.
Wait, so how do you move over?
Yeah, like that. I think you better highlight it. So, hit enter, and I'll pull up here, and hit enter again. And now
He just wants to try.
You could write it
Okay, so how do you
got
do
stuck.
it?
You got stuck because I guess you started another calculation and just hung that up where it wasn't really going to see it. So go to recalculate and just highlight the calculation, hit enter, and then when you see that arrow, even though that's down there, it'll look over.
Okay.
When you see the arrow. If you don't see the arrow, recalculate. Okay, all right. Okay, so the only reason why somebody would miss all of these, and usually if you miss one, you miss them all, is because something happened here, or when you plugged it in, you plugged them all in the same way, wrong. Now you can plug them each in individually if you want, on your home screen on the thing. Plug them each in individually, round to the nearest 10th and go to the next one. Or you can do it this way if you want to be, that's how you want to handle it. Okay? And the last one, number 17. Are you ready? This is one of those that the author calls an inverse function, which I say they're completely nuts about, but it's still a good problem. Okay, so let me show you one of these and how to handle it. Number 17 gives you an equation. This one you actually have to do something with the equation rather than just plug and chug. You got to plug and chug on the first page. You got this one right here. You have to plug and chug 4 times. They just give you the equation. You just plug in the data, the details. Okay. This one, you're going to have to manipulate a little bit. It says something like this. The average speed that a tornado travels is represented by this function. I'll give you one. Like this. S equals 410. We'll say D to the 2/3. Where S is the speed in miles per hour that the tornado travels, and D is the average depth in feet that it digs a hole or a trench. Okay, this is what they're asking you to do on number 17. Oh, crap. I think I'm going to have to make you change this when I give you the test, because the A part says find the inverse of the function. That's not what I want you to do. What happened to my test, because I had it rewritten. I may have to make new copies for you. But what it should say in the A part is, it should say solve this equation for D. That's what it should say. It doesn't have a thing to do with the inverse. So I may have to recopy this for you. So to solve for D, to accomplish that, you would go, first of all, S to the 3/2 equals 410D. Do you understand that move? You do? Okay. And then it would be S to the 3/2 divided by 410, that is D, and that's what you would put in the blank. Solve for D means get D by itself. And to do that, you got to get rid of the 2/3 first by multiplying or by powering to its reciprocal so it turns into a 1. Y'all follow me there? Thought I said the wrong thing, but I didn't. So the A part of this and the answer blank over here, so 17, and we'll say A, you will write D equals S to the 3/2 over 410. Okay? And then B part says, find the average depth of the trench when the recorded speed is 82 miles an hour. So now you got to take this thing and plug in 82 for S and kick out a value to answer the B part. And it's probably, I don't know, I'm making this whole thing up. We'll pretend this is in yards. It's about 2 yards deep, 1.8, is that what you got?
Yeah.
Equals approximately 1.8, and it doesn't say what you have to round to. So the B part, I would just write 1.8, whatever, we'll say yards. Like I said, I'm just making this up. The units will be on here. You should put the correct units on. Y'all okay with that? Now, what would you do if this were 410D to the, and it was like this instead? How would you solve for D in that case?
However, to the F.
Yeah, you go S to the 5th equals 410D. So it doesn't matter whether the exponent, it's written exponentially or like this. To get rid of that 5th root, you've got a 5th power, both sides, yeah? So it would be S to the 5th over 410. I'm not going to tell you which one it is, but you should be able to handle both. And then you use that to plug in some S value to figure out the D that they want you to record. It's not hard. Most people don't miss this.
For the other one where it was like S raised to the 3/2,
Mhm.
do you have to specify that it's positive?
Nope. Because there's context to the problem, a negative value wouldn't make any sense. So we don't even have to talk about it when there's context to the problem. Okay? Think you can handle this test? I will tell you this, if you want to know where to put your study time, the most points are missed on 12 and 13. People just don't know how to add, subtract, multiply, and divide. And simplify. It's the simplifying that kills them. So I'm just saying, those are the ones. That are the most. Okay? All right, that's the end of the test review. Hope you got something out of it, everybody. See you, bye.